purpose of this course is to develop your knowledge of basic statistical techniques and methods and how to apply them to develop the business and personal intelligence that will help you make decisions. The learning objectives for this unit, Unit 1, from our text is first to explain why knowledge of statistics is important. Secondly, to define statistics and provide an example of how statistics is applied. Thirdly, to differentiate between descriptive and inferential statistics. Fourthly, to classify variables as qualitative or quantitative and discrete or continuous. Fifth, to distinguish between nominal, ordinal, interval, and ratio. Sorry about that. Statistics. So first, why study statistics? Data are collected everywhere and require statistical knowledge to make the information useful. Statistical techniques are used to make professional and personal decisions. And knowledge of statistics is needed to understand the world and be conversant in your career. In summary, statistics will help you make an effective personal and professional decision. So I wanted to talk a little bit about this because I think it's important. As some of you may not be um, opposed to taking a quantitative statistics business course, some of you may be excited to take it, and others may be maybe a bit intimidated and or terrified to take it. So I do want to kind of talk about these different positions regarding statistics, and then hopefully help us all get on the same page about how I view us going through this course together. So I certainly have had my share of statistics. I had two master's degrees, or have two master's degrees that I did complete statistics courses for. And then my doctorate certainly had a whole class, at least one on qualitative statistics and another on quantitative statistics, and then spent quite a bit of time through my dissertation applying what I had learned through those various degrees. But quite honestly, I wasn't, terribly excited about it. I didn't think that I would use it very much in my career. My first career was as a clinical psychologist. I later, as I gained some years of experience in that, was promoted to clinical director level. I didn't use statistics very often in those two positions. But then I became involved in my current job, which I am going on 20 years here in the next year, which is therapeutic schools. And what I have found is I have found not only the usefulness of statistics, but I do get excited about statistics at times. And when I do is when I believe that it helps me to tell the stories of my schools and my students to area legislators so that I can advocate for legislation that either assists with programming and or funding for the programs that my particular type of students need. And so in that way, it's become terribly exciting to use the data and show statistics about how um, certain programs that I have been involved in creating for the needs of students in the four counties where I serve have had significant results. So, for example, my most recent program development has been school day treatment programs post-COVID. There have been very much increased behavior and mental health issues along with academics that we are trying to assist students in the various locations, which include residential, detention, jail settings. And so we have really been challenged to create some whole student program approaches and collecting that data and seeing what programs are the most effective increasing those, looking at the right dosage of those programs, both treatment, life skills, social skills, those types of programs to wrap around our academic typical K-12 program to make a whole student day treatment program has been um, really rigorously data bound, and also running the statistics have not only helped us to inform what programming to keep versus to modify or to kind of toss aside and try something else, as well as we are currently approaching putting together a presentation to our state legislators to talk about sustainability funding beyond COVID funding. So I have grown to not only use statistics more, but to appreciate them and even to get a little excited about them, especially when I'm able to use them to tell the stories of the students that so desperately need the services to be successful, and then to see those that are supported through different funding measures through our State Department of Education have an impact. So I did want to kind of tell that story just to personally let you know my personal view, but I certainly have held all three of those that I named, being kind of a reluctant consumer of statistics, kind of going, okay, it's necessary to get the degree, to kind of seeing the usefulness a little bit, but not being terribly excited, to having times where I really appreciate the usefulness of it and telling a story in order to advocate for my programs. And if you're in business and it's a product, certainly we'll talk about some business case scenarios through this course to talk about how statistics can be very helpful in many fields, not just the field of education and treatment like I'm in, but in all different types of fields, including, of course, business, which I think many of you are involved in. So let's move on and continue to talk about the first chapter and the concepts. So what is meant by statistics? Well, it's more than just presenting numbers. It is the science, this is a technical definition, a science of collecting, organizing, presenting, analyzing, and interpreting data to assist in making more effective decisions. So an example might be that does impact our everyday life is inflation. So looking at each year and inflation rates, we can apply statistics and compare, a decade ago versus 5 years ago versus a year ago versus now, and whether those inflation rates are going up, down, staying the same, etc. So that's just one example. And then there are different types of statistics. So there are two different broad types. One is called descriptive statistics, and the other is called inferential statistics. So descriptive statistics can really tell us about data in a way that kind of organizes our thinking or gives us a general sense of the complete um, spectrum of data that we are studying. And we'll look at some examples in a moment. And so, looking at that, summarizing it, presenting it in an informative way, this is very common to do that before diving in and showing things like significance or making inferences. It's really important to understand the data set before we go into those deeper dives. And again, throughout this course, we're going to look at examples of descriptive statistics before we do any looking at inferential statistics. And then we'll talk many case scenarios of how that's important and useful using those two different types of statistics. So this is one example. So we might say that there are 46,837 miles of interstate highways in the United States. And this interstate system of highways represents 1% of the nation's roads. Okay, so there's lots of other roads, like those roads that we travel in our different cities where we live, different communities, suburbs, etc. So 1% is this 446,837 miles that are interstate highways. But that 1% carries 20% of the traffic any given day. So that's interesting to think about, right? So that's why, and I think that that's definitely, fits for just off the top of my head, my experience, where I want, if I want to go faster, but I'll have more cars on the road, if I want to go faster because I'm going on one of the highways versus going on side roads, typically aren't as populated, but you're not going as fast. So anyway, there are times where I don't want to deal with the busyness and I'm willing to go slower to get there maybe a little bit later, but not have that frantic sense of the highways because 20% of the traffic at any given point in time are on that 1% of roads versus those more urban city non-interstate highway roads. And then another descriptive statistic is that Texas has the most interstate highways and Alaska doesn't have any. So those are just some descriptive statistics about roads, interstate and non-interstate. Inferential statistics, however, can be used to estimate properties of a population. You can make decisions based on a limited subset, a sample of an entire set of data, which we call the population. So inferential statistics are the methods used to estimate a property or a characteristic of a population on the basis of a smaller sample of that population. And we'll have many examples of that through this course. An example here is that we might say TV networks constantly monitor the popularity of their programs by hiring Nielsen to sample the preferences of TV viewers. For example, NCIS, TV show, I don't know if it's still on, I know it was for many years, was the most watched show during the week of March 13 through 19 of 2017. A total of 14.16 million viewers watched this show. So, what Nielsen did was they took a sample and made an inference that many viewers from the whole population of possible viewers watched NCIS. So, population is the entire, so it's exhaustive, all the specific individuals or objects or data points of interest or measurements obtained from the individuals or objects of interest. So all of those. The sample is a portion of the population or a part of the population of interest that's being studied. There are two types of variables. We will be talking about this because this is very important throughout the course to talk about the correct statistical analyses to use. You can only use certain statistical analyses on certain types of variables. So certain statistical analyses you can only use on quantitative variables. So if you have just qualitative variables, that would not be appropriate, and vice versa. There are statistical analyses that should be used on qualitative type of data, not quantitative. So very important to understand the difference. Qualitative variables or data is an object or individual that's observed and recorded, but it's a non-numeric characteristic or attribute, so you can't put a number to it. So things like gender, things like a beverage preference, beer versus wine, etc., lemonade versus pop, etc. Your eye color, brown, green, blue, etc. Those are not numbers, but those are qualitative characteristics, and they are considered qualitative variables. Quantitative variables is a variable that is numerical. So examples would be balancing your checking account, the number of gigabytes you used in your cell phone in a month, or the number of people employed within your company. So qualitative variables can be discrete or continuous, or excuse me, quantitative, forgive me, variables can be discrete or continuous. Discrete means that they're the result of counting things, and there are gaps in an equal distance between each of the values or numbers. So the number of bedrooms in a house, the number of students in a house, those kinds of things. Continuous variables are, so it's not like It's not segmented, it's continuous. So there are values throughout 0 to, whatever the endpoint is. So it would be things like tire pressure, duration of flights, those kinds of things. So continuous is not, uh, you know, there can be any number of data points between the end and the beginning, whereas discrete, there are um, segments of the values, and they are discrete, not continuous. All right, so just summarizing qualitative and quantitative. Qualitative, there would be things like brands of the computer I'm using right now. I happen to be using an HP, my marital status, hair color. Quantitative, discrete would be children in my family. Strokes on a golf hole, that's not Stokes, it should be strokes. And TV sets owned. Continuous amount of income tax paid, weight of a student, yearly rainfall. The levels of a measurement, there are four: nominal, ordinal, interval, and ratio. Nominal is the lowest level of measurement, and it also means that there will not be many statistical tests that we can do on nominal variables. It is simply, and the easiest way to remember it is nominus, if you've learned Latin, is number. So it is numbers. So it is simply nominal, naming or numbering things, but it is not, it doesn't give a value. It's simply like categorizing something. Like you categorize different types of animals, cats, dogs, fish, etc. But there's not really numbers to it. It's just a category. Ordinal, or excuse me, I just did nominal. Ordinal is the next highest level, and ordinal means that there is an order, but there's not an equal value between so there's a ranking and then there's an order, but there's not like an equal value between the rankings. So you could say the top 10 states, the top 3 football teams, um, student rankings of their professors, etc. The next level of measurement beyond ordinal is interval. So interval is also ranked, but there is an equal value between each, an equal amount between each value, I should say. And the next level is the same as interval. The only difference is there is an absolute 0. All right, so that's considered ratio. All right. And then let's say just one thing about ethics here a minute, that we should make sure that our data, that when we are collecting data, that we are ethical, and when we're reporting data, that we are ethical, meaning that we are not misrepresenting the data. Often in fields, as I've given examples before in my own life, and we'll find in our business case examples, not presenting data in a true, forthright, ethical way. Um, there's many decisions that are made regarding statistics and data, and we want to make sure to be very careful, because if we mislead, there could be decisions that are very important, like around business decisions that could relate to funding for your company, etc. That if it was misinterpreted or misrepresented, then we might have, we could be in trouble, our company and or us. And it is also not God honoring. So we want to make sure to be ethical regarding our statistics. So that is the end of Unit 1. We're going to fly through our chapters 2, 3, and 4 here for our first week of this course. But I wanted to make sure to kind of explain statistics, the importance of them, the different types of data, and then also the different levels of measurement. So I will see you in the next unit, Unit 2. Thank you.